Are you able to hear me okay? My headset died, and we're doing it on speaker.
Yes, we can hear you.
Okay, great. Thank you. Let me get this set up here. Okay. Should be able to see starting the project, plan and manage schedule is the topic of today's meeting.
We can.
Okay, great. Thank you. There we go. So the objective for today is to plan, prepare, modify, and manage the project schedule based on the methodology that you've chosen for that project. So we're going to take a look at both predictive and agile type schedules and what we need to do with each one. Okay. Enablers are listed here. You need to estimate the project tasks, and they can be milestones, dependencies, story points. There's a whole plethora of ways that you can estimate a project, especially the task level. We're going to talk about utilizing benchmarks and historical data in order to create a schedule. And then we'll learn how to prepare the schedule based on whichever methodology we've chosen. We'll be able to measure ongoing progress based on methodology. And then we'll talk about modifying the schedule as needed. And that'll be based on the methodology again. Whether it's predictive with a long lead time between the signing off on requirements and delivery of functional product, or an agile project where there will be many more opportunities to assess the progress of the overall effort and make small changes rather than large ones. And then we'll talk about coordinating with other projects and other operations, as we usually have at least either vendors, whether they be internal or external, contributing to the project itself. And we need to understand what types of methodologies they use and how we can best meet up with them at the correct point in time. Okay. Deliverables and tools, and we get to go to a second slide on this one. So deliverables, activity cost estimates, dollar-wise, activity duration estimates. This is the number of staff days, staff weeks, staff years that it takes for a particular task. We talk about task, story, and feature estimates. We group these together as they're really going from bottom up. The tasks and stories encompass a number of tasks, and then a feature will be created by using multiple stories to fulfill that feature. We'll have updated documents, naturally, and believe it or not, yeah, the old project plan needs to be updated. We'll also be working with a backlog so that we'll understand what still needs to be done for the project, the importance of what needs to be done, and where any changes or any additions or subtractions would be affected, would affect that backlog. You can add to it, you can remove from it, but that's really what you're working with. It's the overall backlog. Velocity data is basically how much work a particular team can get done in a time box. So with Agile projects especially, you'll see things, you'll see in the tools that are used, just a way to inquire about velocity for any team. What we do is we take an average over time. We'll look at the complexity of what's being done by the team, how familiar they are with it too. But velocity gives you like a wet-fingered guess as to how much they can get done. It's all based on having good estimates for each of the tasks or features or stories that they're responsible for, that they're taking responsibility for. So anything like that velocity data, any of these estimates are really only as good as the data we use to create them. We'll also have the project schedule itself. Try to slip that in on the bottom line. A release plan, so that we understand when the functionality is planned to be delivered. Product roadmaps, so that if some features need to be deferred, we need to update the product roadmap to accommodate that. We'll also do an earned value analysis so we can understand how far ahead or behind our estimates the overall project is. We'll update the schedule. We'll update the release plan and the product backlog, as we talked about just under the general backlog topic. Network diagram, if necessary. We're going to have a ton of planning meetings, and I don't care whether it's a predictive or an agile effort. The planning meetings really are used to either put together the deliverable schedule or to help determine what can be delivered within that particular time box. And then, especially if you're working directly with the customer, or this is also with your development team, negotiations are involved. What can be done, what can be released and delivered in a particular time box. If things can't be delivered, what's the trade-off? Things like that. So, project manager who's in charge of either a predictive or an agile project would get involved with negotiations internally and potentially externally to make sure that the project stays on track. Tools that are used. Types of estimating, top-down estimating, expert contributions, analogous estimating, parametric estimating are used. So bottom up, you can use a roll-up of all the WBS packages. So in the first one, you're using expert opinions as to come up with an estimate. On the second one here, bottom up, you're waiting for the individual development teams to estimate their efforts and then rolling those up to find out what the overall effort is for features, or they don't mention it here, but efforts. T-shirt sizing is used. This is just an order of magnitude of the overall effort, anywhere from like a small to a double extra large, or extra small to 3X. It depends on the range that you feel is appropriate. Estimating using Fibonacci sequences, and these are usually buried in things such as planning poker decks. And planning poker really is just a way for a team of people to come up with independent estimates, the effort for, say, a task or a feature. Each person has a deck of cards that really is it's a modified Fibonacci sequence. It would go 1, 2, 3, 5, 7, 12 as an order of magnitude of the estimate. Okay. So what you do is with that, with planning poker especially, each person estimates for themselves what the effort would be, and at 2, 3 go, and you flip over your card as to what your estimate is. If you've got any outliers, say someone estimated it as a 1 and somebody estimated it as a 12, then you have a discussion. You have points of that you can discuss to understand why they thought it was going to be super simple or why they thought it was going to be extremely difficult. And that way, you really just exchange ideas, and you're able to take the best knowledge that you have at that point and use that for your estimates. Now, story points are, one second. Story points are a way of estimating how much effort goes into creating a user or fulfilling a user story. They are time independent. It's just an order of magnitude rather than a time-based effort. So if something would take, say, 7 story points, you'd figure, you can give a rough estimate on time, and I'll tell you, leadership will push you and push you and push you to translate this into time and to expenses. The best thing that we can do is to make sure that story points stay story points. They're independent of time. Story points, the overall effort's going to vary from team to team. If you've got, say, 3 teams, one experienced, one semi-experienced, and one who's doing something for the first time, given the same task, the estimates will be different. The inexperienced team probably won't be able to complete the task in the same amount of time as it would take an experienced team. Okay? So handling story points for some teams is more difficult than others. And it works all the way around, too. Relative estimating, affinity estimating, PMIS, these are just types of estimating techniques that you can use. PMIS actually stands for Project Management Information System. So it's more of a tool. Historic database should be, plus any of the constraints that we have to live within, based on the corporation itself, any regulatory issues, things like that. It should also be a way to display schedules, things like that. A Microsoft project would be a project management information system, component of a project management information system. Okay. So we'll also have process assets, exactly how we're supposed to be doing things. Backlog management, we have ways, as where the backlog is actually maintained by usually product owners. So they determine what the sequence is, or what the value of delivering each feature is. Naturally, we've got release planning, which is when we're able to get into the lab, if necessary, how we're able, what time frame we have to test these, some of these projects that require multiple systems, and just making sure everything like that's set. Along the same lines, iteration planning is slotting the features into a particular iteration or time box. But we'll also have, once the development teams get rolling, we'll have burn down and burn up charts. Burn down and burn up are just basically mirror images of each other. With burn down, you take the total number of features that the team is committed to within that time box, and you track how they fulfill or complete each of those features. So the chart starts off at basically a horizontal line at the total number of features committed, and then we'll head in a diagonal line towards 0. So ideally, by the end of the iteration or the time box that you're dealing with, you would have completed all of the features that you'd committed to. Okay. Same thing with burn up. You start at 0. Burn up just tracks how many that you've completed. It's an additive. Burn down is a subtractive way of doing it. Cumulative flow diagrams. These are kind of nifty. Multiple colors and everything. That can be used to track the progress of the overall project. Throughput analysis, especially if you've got a lot of data flowing between systems, that may be extremely valuable to do. Velocity analysis is really talking about, again, how much can be done within a time box. Retrospectives are a very, very valuable tool. And what you really want to do is at the end of any time box, say an iteration or a program increment, you want to take a look at what worked well, what didn't work, and take the things that didn't work and identify, say, your top 2 or top 3 things that didn't work well, and put together plans for the next iteration or for the next time box to be able to improve the performance based on that. So this can be a very valuable tool. The teams that I've coached that take retrospectives seriously have shown that they can improve their competence in an agile way, almost exponentially, because they're taking a look at and analyzing what didn't work well, what did work well. You usually will start out where a retrospective is, you don't know what to do with it, and so you go through the motions. But as your experience builds, the retrospective then becomes much more focused. It becomes really a tool rather than just a ceremony to go through. In case I didn't mention it, I think that retrospectives are extremely valuable. Okay. Review of work produced. Backlog, they should put all of these things together with backlog. But backlog reprioritization is taking a look at the overall backlog, determining what's still remaining, and ideally for the next time box, making sure that you have the right features in that backlog or right tasks in that backlog in a priority order. But scaling projects really is taking a more simple or smaller instance of what you're going to be working on, and just take a look to make sure that you're within the ballpark of what you should be. based on the size difference. And you're going to have meetings, and more meetings. Again, I mentioned that you'll have with the development teams on a continuing basis. And ideally, project manager, I don't care whether it's an agile effort or it's a predictive effort, should be talking regularly, I'm talking at least once a day, with the people who are their suppliers and the people who are their customers. Okay. And then procurement negotiations, you need to represent exactly when deliverables are going to be required by the development teams, and also when the development team efforts are going to be available for the end customers for either testing or actual use. Okay, we're going to start talking about some of the definitions here. So a project schedule is an output of a schedule model that presents linked activities with planned dates, durations, milestones, and resources. This is definitely for a predictive project. With an agile project, it doesn't necessarily have as many linked activities. As you can see in the example here, we have relationships between activities where, say, the next activity can't start until one's completed. Okay, and this is all a finish to start relationship shown in this example. Now that's all well and good if you've got a predictive model and you've got a single team working on it, and they need to fulfill the, to work on these features in a particular sequence. Now, for agile projects, you really want to make sure that you have an architecture that supports an agile implementation so that you will not necessarily see any finish to start relationships. There will be some, but for the most part, you're going to be able to do a lot more in parallel and bring them together in a staged manner, so that you will be creating things such as minimum viable project or products. You may hear that one, the MVPs, or minimum marketable features, which literally means that what you're going to be creating is something that the customer can use. It's not necessarily a complete implementation, but you use it for feedback from the customer to see if your implementation matches their expectations, okay, and that it's useful. That's the minimum marketable feature. That's a minimum viable product, okay? And then you start layering on top of it these minimum marketable features so that you build up what the customer has from a small core to a fully functioning product. The schedules will look different, as I said, okay? But know these things about the overall project schedules, especially predictive. Include start and finishing activities on specific dates and in a certain sequence. This is especially predictive because, as I said, agile project management requires a lot more flexibility. Specifies planned dates for meeting project milestones. We may still need to do that, but milestones are different in an agile project than they are in a predictive project. Predictive, we have certain milestones that are established way up front that we've been managing projects like that for years now. We have the M gates, and people have a common understanding of that. And those are the things that you're trying to achieve. You know, where you say that your requirements are done, that you're ready for testing, things like that. Now, with an Agile project, the milestones, really, the plan dates, are usually the ends of the time box that you're working with. As I said, that's either a program increment or an iteration. The milestones before that are usually ones where an external vendor is going to be supplying the team with a component that's required to be used to implement all the features or some of the features in that particular time box. So slightly different. With a predictive project, we were talking about some fixed milestones that are declared when certain certain components are met. With Agile, it's really when things are expected or needed by the team. Okay. Also, the schedule coordinates activities to form a master plan in order to complete the project objectives on time. Again, to keep it within the context of that particular time box for Agile projects. It also tracks schedule performance and keeps upper management and project stakeholders informed about the project status. Now, as you can see here, this is a Microsoft project schedule, which is all and great, all well and good. But what we're looking at as far as Agile-based tooling is the ability for leadership to actually pull up the information on demand using either dashboards that are implemented using Power BI or are part of a tool set. So we want to eliminate any slideware that has to be done and make it more interactive with leadership, get them used to actually taking a look at the schedules whenever they need to, rather than on a scheduled basis. We should go forward, I think. Benchmarks and historical data. When scheduling, benchmarking is the comparison of a project schedule to a schedule with a similar product or service produced elsewhere. In this benchmarking, the elsewhere can be either internally to the corporation, the company, the team, or it can be external. If it's something that's absolutely brand new to the corporation that has been done by other companies or corporations previously. Usually corporations are pretty generous about allowing others to benchmark some of their achievements. Okay. And benchmarks can be useful in the initial stage of scheduling to help assess the feasibility of a project. That way you can see exactly how long some implementations have taken, and to judge whether or not your estimates are within the same ballpark, at least, of your benchmarks. Now, historical data can come from other projects completed within an organization for which detailed information is available. You may be able to go to an external organization too. Depends on what you're looking for. And then historic data provides a good starting point for how long something should take prior to detailed analysis. So you're really just trying to get a ballpark estimate of how long the implementation should take. Schedule management plan is a component of the project or program management plan that establishes the criteria and activities for developing, monitoring, and controlling the schedule. So, keywords: develop, monitor, and control. Okay. You may find some questions on the test as to when a schedule management plan would be applicable. Okay, so this describes how activities will be defined and progressively elaborated, identifies the scheduling method and scheduling tool to be used, determines the format of the schedule, whether it's a Gantt chart, whether it's a burn down chart, whether it's a burn up chart, whether it's a set of charts produced by the tool itself, and establishes criteria for developing and controlling the project schedule. Okay. Components in the schedule management plan are project schedule model used, so whether it's predictive or whether it's agile. Accuracy of activity duration estimates. This can be based on historical data, can be based on benchmarking. And what should do then, as part of the schedule management plan, show the actuals with that too. The units of measure to be used, and whether you're talking about weeks, days, months, whatever. Also, at this point, that would be the duration units of measure. Organizational procedure links used with the WBS in case there are specific procedures that need to be followed. Control thresholds to be used for monitoring schedule performance, establishing an upper and lower bound, so that if your performance is within the upper and lower bounds that you're on schedule, above the upper bound, it looks like you're ahead of schedule. Below the lower bound, and that's where you start raising jeopardies in a predictive project. Rules of performance measurements to be used, reporting formats to be used, whether it's supposed to be a piece of paper every 3 weeks or being able to see it on the dashboard within an hour of completion of a certain thing, such as a test suite. Process descriptions to explain how schedule management processes are to be documented throughout the project. It's just, how do you modify it? How do you amend it? Schedule management considerations for agile or adaptive environments. Total project timeline may be developed, but individual activities are scheduled iteratively, so that you don't necessarily have the finish to start relationships. Two main iterative approaches are iterative scheduling with backlog or on-demand scheduling. Here you've established what needs to be done next, and then on-demand scheduling is really being able to put together a schedule based on historic performance and the tasks that still need to be completed. Iterative, okay, I'm going to pay somebody to say this for me. Iterative scheduling with the backlog. So you have progressive elaboration. They call it a rolling wave technique. So know both. Hold on. Know what a rolling wave is. Know what progressive elaboration is. Okay. Used to schedule activities. Uses a specific time window, often 2 weeks, and this is what I've been talking about, like an iteration or a time box. requirements defined in user stories. I'll elaborate a little bit on this here, but what you'll see in a good user story is the way that the particular module that it's defined in the story or in the feature is going to be used, and then the acceptance criteria, which are really part of the user story, really define the parameters that need to be tested for, and you would historically think of as requirements. Okay. You'll have your stories prioritized, stories selected based on priority and time box, when you can fit in the development. Say you have a particular team that's required to implement 2 large critical pieces of your project. They may not be able to do both within a particular time box within an iteration or a program increment, so that you'd really need to be aware of that and schedule it accordingly. Make sure that the remaining stories are added to the backlog. Instructed the schedule and associated work is constructed later based on the priority. Okay, because you could have, say, some short tasks that have a big impact, which would be scheduled first, as opposed to, say, several long duration tasks that are necessary for the project but are not critical. Okay, so that your schedule can change based on when you have to implement tasks of different durations and priorities. The Agile efforts are going to deliver business value early and incrementally, as we talked about the minimum viable product, being able to deliver that to a customer so that they get a look and feel of what the overall deliverables will be, and then incrementally adding to that functionality. Going to be able to allow changes and adaptations during the entire project, rather than going through a large change management process. It's a lot more straightforward with an Agile effort. Now, it does not work well when there are complex dependency relationships. Now, a couple of things here to me. We have complex dependency relationships. We should look at a way to minimize that to begin with, because complexity is the worst enemy of good software, especially. And with some of the ways of scaling Agile at this point, the complex dependencies or relationships can be accommodated by the tooling and by the processes to follow. But know this response. You may get a question on the test that is going to require you to answer it like this. Okay. No matter what I'm telling you, remember, you go with the definitions that are shown here, that are in the PMBOK guide, and in any of the literature that is suggested that you read. Yeah. Talk about on-demand scheduling. It doesn't use traditional schedules. What happens is the team members pull work from a queue or a backlog when they're available to work on it. It's based on Kanban and lean methodologies. Now, Kanban is a way of representing what's going on with a number of parallel efforts. And it really just moves the effort through a defined number of stages. Stages can be ready to be worked on, prioritized, implementation, and then tested and deployed. There's things like that. You just progress your deliverable through those stages. Lean methodologies. Lean is developed as a result of in the automobile industry in Japan. So there's a lot of literature out there about lean methodologies. On-demand scheduling also provides incremental business value. It levels out the work of team members because once you get finished with something, you're expected to pull something else off the backlog or out of the queue. And it works best when activities can be divided into equal amounts. Now, this, again, is dependent on the capabilities and experience of the individual team members who are pulling from that backlog. Okay. And does not work well with others when there are complex dependency relationships. Some guidelines to develop a schedule management plan. Review the project management plan for information to develop the schedule. Review the project charter for a summary of high-level milestones, what the schedule is. Review the enterprise and environmental factors. Review the organization, process assets. Use tools and techniques such as expert judgment and historical information. So expert judgment, you may pull some people in for that. Could be internal to the corporation. Could be a consultant with that expertise outside the corporation or outside the team. And then use meetings to develop a schedule management plan. So it's not just getting together with the implementation team. It also requires working with customers to talk about trade-offs, things like that. Then document the schedule management plan for the project. An activity is a distinct scheduled portion of work performed during the course of the project. So in general, the terms activities, work packages, and tasks can be used interchangeably. Usually each of the methodologies will have its own way of expressing it. So you need to understand what the methodology uses and be consistent in the vocabulary. It's a very important concept that the entire team understand and speak in the same, using the same vocabulary as everybody else in the team. It allows people to understand without having to think about it what you're talking about. So if your methodology says that you refer to team activities as work packages, you refer to you only use the term work packages. Don't use tasks, don't use activities. Okay. What you want to build up is a common vocabulary for that development team and for that leadership team. Okay. So this project management environment each has a distinct meaning. Work package is the lowest level of the WBS. Activity is a smaller component of the decomposed work package, and a task is used when referring to project management software. Know the definitions here. Features are used to group related functionality together to deliver business value. And really, that's what we're doing. We want to deliver business value to our customers so that they can do their jobs better, they can increase their revenue, and for AT&T, or whichever corporation you're working for, to be able to maximize profits. Activities and efforts such as documentation, bug fixes, testing, and quality defect repairs are also features, depending on the methodology used. Features deliver the capability that can be estimated, tracked, and managed as a set. Features allow scheduling aligned to features, ensures associated work is coordinated across the board. Estimating features offers a view of when blocks of functionality can be released to the business and to end users. And progress can be measured based on the features that have been accepted compared to features removed. So again, your burn up, burn down indications. Oh, I think we skipped. Okay, milestones. Significant point or event in a project, program, or portfolio. Historically, we've had the gates that we try to achieve in a predictive project. With Agile, we take a look at more the concept of what's being delivered, what type of functionality is being delivered to the end customer. Guidelines for estimating project activities. Review the schedule management plan. Review the scope baseline for the WBS, deliverables, assumptions, and constraints. Review the EEFs and OPAs. Analyze and decompose each work package of the WBS into activities that will be required to produce the deliverable. Consult SMEs about unfamiliar material. This is expert judgment here. Evaluate all constraints and assumptions for their possible impact on activity definitions. And once you've decomposed each work package into activities, evaluate your activity list. Make sure you're not doing redundant work. Make sure that any gaps are covered too. Again, we don't have an activity. Okay. Activity dependency. An activity dependency is a logical relationship that exists between two project activities. Relationship indicates whether the start of an activity is contingent on an event or input from outside the activity. And that can be a deliverable from an external vendor or a vendor within the corporation too, a vending team. Activity dependencies determine the precedence relationships. So if something can start in parallel, which would be ideal, you could work on multiple teams. You want to identify that. And you also want to identify any activities that are going to rely on the completion of other activities. And then activity dependencies, yep, covered that. Example, designing room layouts. An architect needs to assess the functionality of his room design. Assessments can't start until workers finish framing the walls, windows, and roof. After the structure is in place, then the architect can reassess design plans to determine if modifications are necessary. Just see whether or not the implementation is going to work. A couple of, four different types of activity dependencies. Mandatory is a relationship that is contractually required or inherent in the nature of the work. Something like this is not starting laying concrete for a road before you get the approvals from the state, the local, you know, the village, or whoever needs to sign off on it. Discretionary type of dependency is a relationship that is established based on the knowledge of best practices in a particular application area or an aspect of the project where a specific sequence is desired. So this is putting things together in a logical manner that gains something for the development team or the customer or both. External, we've been talking about that. It's a relationship between project activities and non-project activities. You can use that also for making sure that you're covering things such as offshore vendors or offshore teams, a holiday schedule, things like that. And then internal dependencies, contingent on inputs within the project team's control. So if there's a certain sequence that has to be, that the work has to be done in, then this is what we're talking about internally. The precedence relationships, a logical dependency used in the precedence diagramming methods. Logical relationship between activities that describes the sequence in which the activities should be carried out. Now we'll cover it in the next slide. You get a graphic of this. Each activity has start and finish dates. Precedence relationships are always assigned to activities based on the dependencies of each activity, such as predecessor activity drives the relationship and most often occurs first. So the activity on the left usually needs to be completed before the activity on the right starts in. Successor activity is driven by the relationship. So it's, for example, if you're building a road, cutting the relief joints into the concrete necessarily has to wait until the concrete's been poured and has had time to cure properly, at least to a certain point where you can use the tools that they use to put the expansion and say the expansion joints in. Okay. So finish the start relationship. Activity A has to finish before activity B can start. Start to start, activity A and activity B can start at the same time. And finish to finish is that activity A and activity B have to finish at the same time. Then start to finish, activity A can start once activity B is finished. Some guidelines to sequence project activities. What you want to do is review the schedule management plan for information on the scheduling method and tool, and information on how activities may be sequenced, whether you're using Microsoft Project, whether you're using Jira Align, you're using exactly what tooling you're using, and how those relationships can be represented within the tool. Review the activity list for all project schedule activities. Review the activity attributes for each activity. Review the milestone list for the dates for specific scheduled milestone events, either predictive or agile type projects, so that the milestone list may be a list of just things that need to be accomplished before you can start the next phase of the project. for predictive. Agile is more when things need to be completed or when an external vendor, whether it's external to the team itself within the same corporation or outside the corporation, needs to deliver a component to the development team. Review the project scope statement, review EEFs and OPAs, use tools and techniques such as PDM, dependency determination, and leads and lags to develop the project schedule network diagram. And then document the project schedule network diagram and update any project documents as needed. Okay, duration, activity duration estimates are the quantitative assessment of the likely number of time periods that are required to complete an activity. So remember we talked about some estimating methods before, the 3-point, optimistic, pessimistic, and most likely. Boil it down and you'd come up with one duration estimate. Elapsed time is the actual calendar time required for an activity to progress from start to finish. And then effort, the number of labor units required to complete a scheduled activity or work breakdown structure component. It's often expressed in hours, days, or weeks, and it's contrasted with duration itself. Duration only accounts for the total number of days required or total number of time periods. Effort is the number of time periods multiplied by the total effort in each of those time periods. So if you've got a requirement to work, where one person would work an hour the first day, 2 people 8 hours each second day, your effort for that simple task would be 17 hours. Okay, but your duration would be 2 days. So know the distinction between duration and effort, and also elapsed time. Guidelines to estimate activity durations involve the work package owners or others who are very familiar with the work for the activity. Make sure you consult lessons learned and historical information. Review the schedule management plan. Determine how you want to quantify the work that needs to be done. What's left to do. Consider resource requirements, capabilities. Review the resource requirements for each activity. Make sure that you're not double booking people or scheduling them for more than, say, 24 hours in a day. Check the resource calendars and determine when resources are available. And resources can be either, in PMI's case, can either be people or other types of resources such as concrete or compilers or specific machines, things like that. Okay. Also, consider interactions with other projects or operations, and review the project scope statement for any assumptions and constraints that you may have missed before. Review the risk register to consider any risks that may affect resource estimation. And review the resource breakdown structure of resources listed by category and type. Make sure that you have exactly what you need to complete the project. Use tools and techniques and document the activity duration estimates. Different schedule presentation formats are Gantt charts, milestone charts, project schedule network diagrams with dates. These are the ones you need to know here. Practically, you'll also be seeing like, dashboards and actually interactive tools that will allow you or leadership or any of the developers to take a look at what the progress is. Okay. Talk about a Gantt chart. A bar chart is scheduled information where activities are listed on the vertical axis. Dates are shown on the horizontal axis, and the activity durations are shown as horizontal bars placed according to start and finish dates. With the Gantt chart, it shows the start and end dates, duration, and order of execution of tasks. It shows precedence relationships, again, the order, and also if a task is dependent on a previous task being completed or a sibling task being started. Shows percent completion and actual progress. The bars will become colored in as you progress. And then it's used to present project status to the project team and management. And this is what you need to know for the test. These areas here, and this is where you need to study. I will tell you that we are, as I said before, going to more dashboards, more interaction with leadership, so that we're trying to eliminate the need for slideware to be produced, especially for agile projects and safe efforts. Okay. Milestone chart provides a summary level view of a project's milestones, uses icons and symbols, like the diamond here, the half diamonds here and here, things like that. It's basically used by upper management, and they're usually not interested in fine details. They just want to see when something's going to complete and when they can start meeting on customers to pay. Okay, project schedule network diagram with dates. So these guys are always fun, predictive projects. You can do a lot with these network diagrams, and really what you're doing is you're going to break these into activities, and then you're going to string them together to illustrate what can and what can't be done in parallel, and what your critical path is. So in this case, you align start and finish dates to activities. Okay. So you've got a start date, end date. This is start date and end date. This is early start, early finish, late start, late finish. And this is duration. And this is just a number that indicates which activity it is. And you can get that from the WBS. Or this can become part of the WBS. Yeah. And it also communicates the project status in terms of activity precedence relationships. So as you can see here, you need to do activity A, then activity B. And once B is completed, you can start in parallel activity F and activity C. I don't know if you've gone over this with your mentors or in reading the books, but in this case here, TF means total float. And remember that your critical path is going to have 0 total float. There's no float in the critical path. Float meaning a number of time units that you can delay the start of a particular task without affecting the delivery date. the last date of the project. So in this case, the activities up here have a total float of 11. They're because the duration's down here, all right, is 28 days, hours, whatever. And this is 25. What? Yeah, 25, 28. So you take a look at the early start, early finish relationship. Here, it's 61 minus 50. So that's how you get the total float. You should be able to do that, yep, with the late start or the early start numbers here. But network diagrams historically have been a decent amount of the test. So critical path, we were talking about that. Sequence of activities that represents the longest path through a project, which determines the shortest possible duration. Okay, and as you can see, what we had here was activity 1 being 6 weeks, activity 2 being 4 weeks, activity 4 being 3 weeks, activity 3 being 5 weeks, and activity 3 being 5 weeks, and activity 5 being 4 weeks. So, take a look here. Since they're equal up to here, we have 4, 3, 7, and 9, so that the critical path goes through the larger number. Okay. Because working on these tasks here or activities, you could take up to an extra 2 days and still not affect when the finish line is here. Okay? So critical path activity and the activity on the critical path in the project schedule. Again, we talked about the different paths that we have. So A, B, F, G, H is our critical path. Activities such as these, they're split into multiple parallel efforts. Okay, are included in each of the calculations. So that well, this is the critical path is A, B, F, G, H. Okay. That these activities are also performed when you're off the critical path. So like A, B, C, D, E, H is a legitimate path through there. That's not critical because there's a total float of 11 possible time units.
Harry, I have a question.
Yeah.
Just to help out a little bit here. Will the critical path in a project always, without question, remain the same?
What do you mean?
That was kind of a loaded question. So the critical path, while we're looking at it on paper here and defining it obviously correctly, it doesn't always, it can change, I guess is what I'm asking. Can the critical path change through the duration of a project?
Oh, definitely. Definitely.
Thank you.
If you had a delay up here that accounted for, say, 2 weeks, okay, that would become the critical path through here because you could finish these activities before you could finish these. Mm-hmm. So yeah, definitely you don't just calculate it once. You have to go back through and assess your network diagram, make sure it's still accurate, and then plug in your dates and your durations, taking account of any changes that had occurred since the last time you did it. So yeah, definitely it can change.
Thank you. There was another question as well, if you don't mind. When we take a look at those parallel activity paths, determining the total float, while we can see early finish, early start, late start, there's a delta of 11, which seems obvious, but it's how did we get to that? So let me restate the question. The overall, so the duration of FG, duration of your critical path, is what helps us. How?
Say that one again, please.
Sure. I'm not asking the question very well. I'm trying to. So when we take a look at the total float,
the total float and the free float.
That's right. Yeah. There's a difference between early start and late start of all of those activities, but nowhere else on the actual critical path is there a difference between early start or early finish and late finish or late start. So what I'm asking is the total float, the difference that we have between the early start and late start is really defined by the critical path, and I thought maybe you could elaborate on that.
Oh, you would nail me on that. I haven't taken a look at these in 2 years.
I can help with this. so let me try it a separate way, because again, I want to make sure that I address the question, and even me trying to ask it, the question again is confusing in itself. So let me try to help provide a little bit of insight in here, maybe just a different voice. So when you take a look at your critical path, you have these two activities, C, D, E, and you have F and G, which are happening together, right? And the reason why we see that gap between early start and late start in that top activity is because while these activities are completing together, there's one that takes longer just because the durations are longer, 16 and 12. So that means that you have a little bit more time to give to that C, D, and E activity. And that's really what that float is. You have an extra 11 days that you can take for C, D, and E before F and G finish. So I wanted to make sure that everyone got that, and that the questions that we see coming through Q and through chat, that maybe that helped a couple folks out.
Okay, let me do this.
Mm-hmm.
I've got some research that I put together when I was mentoring that go into how to calculate all this. And this will be, I don't know if it's in the current books or not, the study guides. It should be on how to calculate this. But what we're talking about here is the difference between the early finish and the late finish here. Total float.
I think even more so than that, Harry, maybe even simpler than that. It's really just how did we get there, right? Why do we have this float thing? I think is more of what the question's at. It was hard to. A couple folks might have had a challenge taking a look at this and saying, okay, here's why this works this way, and it's maybe a simpler question that I'm making it. Yeah. Yeah,
it just is a function of the network diagram here, because these three activities have to be done in sequence. They don't depend on activities F or G. Now, what we're taking a look at is, and F has to be completed before activity G starts, okay? So you've got a total duration here, which is 4 plus 8, 12, so 25 here. Total duration is 25 units of time. Here, it's 28 units of time. So you know that this is going to take less time to do. This, the activities F and G require the more time. So the difference between when this one starts, when this one starts, and the duration of this one and this one, and all down the line, okay, is why you have float. If these are different, you have float. If these happen to be the same, okay, add up to the same, you may not have any float at all. You may have the critical path would be the 2 right there. You'd have to keep an eye on both. Does that make any sense?
It does. I think the next question that I would have is if anyone caught what you said there. So you had durations up top, 4, the DUs, 4 plus 8 is 12, plus the 13 is 25. The
Right.
DUs on the bottom are 16 plus 12 is 28. There's 3 delta with 11 float. Does anyone know why? Where's the other 8 days?
It's because of when what the early start is for each of these.
Well,
Okay, the early finish. If you take a look
right.
here, okay, your early start, your 25 or the 25th. Let's use days. 25th day, and it would take you until the 29th day here. Okay. So at and your late start 36 and 40. Okay. So total float here is early start here minus early start here, early finish here minus early finish here. So it'd be 11.
That's right.
And then 49 and 61. So that's 20. Sorry. It'd be 12 here, which, yeah, naturally, which is your duration.
Yep.
Yeah.
I didn't mean to put you on the spot there, Harry, but I think where I was going with this is while you look at the durations and the durations between the top sequence and the bottom sequence have a delta of 3, the extra days, and what this is helping us do is to really make sure we're looking at these things when these types of questions come up on the exam. Understand these. On the bottom row, the early finish is 41, but the early start of the next activity is 49. That's where that extra 8. There's an 8-day gap in there, which is why we have our actual 11 days of float. Thank you.
Yeah, 11 plus the 3 delta. Because you're taking a look at when the activity can start, the duration of the activity, and then when it would finish. Okay, so if you take a look here, your early finish is 61, 61st day here. Your early finish would be 50th day here. Okay. That's the other way of taking a look at it. This early finish takes into account the duration of this activity plus any of the time taken between the 2, okay, plus the early finish of the any preceding activities.
I need to ask what I feel is a dumb question. What is the reasoning for the finish start lag of 8 days? Is that in there because the project schedule is saying that it needs to be in there? Was that something that we're forecasting? Okay.
No, it could be something, say you're building a road, it could be the time that it takes the initial pour of concrete to cure.
Okay, that's where I think I was missing all of the, like I was getting most of it, but I've totally missed the 8-day lag in the middle. Okay, that makes a little bit of sense.
I did a horrible job trying to ask that question the way that it was coming to me, so I apologize if I created confusion there. But yeah, this is something that I think regularly, it consistently gets questioned. This is why I wanted to make sure that we we had an opportunity for Harry to help us out with that. So thanks, Harry.
Sure. One thing I will say is that some of the older Mulcahy books really went into good detail on this. So you may be able to borrow one from the library just to review that type of question. But they definitely, there's definitely a science to it. It isn't just you know, pull a number out of a hat. Now, the other thing you can do too is prepare your mentors and then go over this with them. They should be able to give you a better representation and have some potential activities worked out so that you could create one of these on your own. It used to be that in the test you had to create the network diagram, then answer questions based on the network diagram. So put some effort into it, please. I'll take a look and see if I still have some of that old documentation around and see if I can upload it to the SharePoint. I at least had a few exercises. It may take me a day or two to do that. Okay. Any other questions around here?
I'm not seeing any more on my side, Harry. Thank you.
Okay, thanks, Will. Okay, float is the amount of time an activity can be delayed from its early start without delaying the project finish date for the consecutive activities. Okay, we'll take a look at the network diagram here again. We've got a 7-week duration for activity 2 and 4, and a 9-week duration for activities 3 and 5. And what they're saying here, which I agree with, is that there's 2 weeks float for these guys here, because you've got, said 7 weeks to complete, and this would take 9 weeks to complete. So you've got 2 weeks of additional time that you can work on these. So the total float is the amount of time that a scheduled activity can be delayed or extended from its early start date without delaying the project's finish date or violating the schedule constraint. So total float here, you could start, you have to figure out what the float is for this particular branch. Okay, you said early finish here of 50, early finish of 61. And that's, that'll be your total float. And so activity C, D, or E could start up to 11 days or weeks or whatever, 11 units of time later than the early start date of activity F. Okay. Free float. Amount of time the scheduled activity can be delayed without delaying the early start date of any successor or violating the schedule constraint. Now, if you notice here on this branch, your early finish dates are the same as your early start dates. What it's saying is that you finish activity C on one day, or on one day, and that same day you start the next activity. So without delay, so at this point, there's zero free float because these guys, activity D starts really at the same time activity C finishes. Okay. Same thing here. Early finish and early start of 37. Now, the free float for activity E is calculated by taking a look at activity H, which has an early start date of 61, 61st date, and this early finish is 50th date. So the free float here is 11. So you can't delay either activity C or D without affecting the early start date for activity E. That's all we're saying with the free float. Okay. But really, preferences for this go through a number of exercises for calculating total float and free float. Learn how to, how to fill these things out, and practice, practice, practice. As you can tell from me not having that resource available and having checked it. Okay. How about agile release planning? 3 releases planned. In this case, as it says here, the release plan establishes the iterations so that at this point you've got multiple iterations going into release 2, or release 1, some more into release 2, some more into release 3. Then your iteration plan takes into account what it's going to take to implement 1 or more features in that time box. Okay. So if you've got feature A having multiple user stories, say the first user story being broken up into 4 different tasks, total duration of 29 hours with allocated this way. What you want to do is slot these features into particular iterations. Okay. What you'll do is you'll determine what can be delivered going that way. You take a look across here for the features, any critical resources, any critical people that are required, or any critical lab time, things like that, machines that are required to implement these particular user stories need to be taken into consideration. So that if you've got these 4 tasks, okay, can you also do user story 2 at the same time, or do you have particular people who have to work on these particular tasks in order to deliver in that time frame? Also, if you want to do feature A and feature B, for example, in the same iteration, will you have the testing resources to be able to verify that both user stories have been implemented correctly? So there are trade-offs. You need to keep those in consideration. Ongoing progress based on methodology. We're talking about measuring the project's progress with respect to the schedule. Consists of monitoring the status of the project, update project schedule, and managing changes to schedule baseline. With Agile, we tend not to have the baseline. Always go with the CI definitions. In an Agile approach, you evaluate progress by comparing the total amount of work delivered and accepted. And this is a key point here, accepting the work itself to the estimated work to be completed for the current time period. You review the completed work in regular sprint demos. This is a key concept that whenever you complete a user story, for a feature, what you want to do is demonstrate that to the other development teams and to the customer. Conduct scheduled reviews to record lessons learned or material for retrospective. Determine the rate at which deliverables are produced, validated, and accepted. So this is your velocity. We have coordination with other products. If the project is part of the program or portfolio, schedule status of the program should be evaluated for any effect it has on the other components of the program or portfolio. Some situations, delay or acceleration of a project may not impact other projects. You may have float, and if you finish early, it's not going to affect anything either. There are cases where if a delay or acceleration is caused by activities on the project's critical path, and that project is critical to the schedule of other projects, the overall effect can be significant. It's just saying that you need to understand the relationship between your project and the other projects that are depending upon it or ones that you're depending upon, and make sure that anything along the critical path is completed per schedule, or that if that's impossible, to notify those teams that are dependent upon you that you've got a delay. Let's say it. We need to cover learning goals, and then we have a few things to think about for the next module. Okay, so learning goals: assess project needs, complexity, and magnitude to determine the appropriate project methodology or methods and practices. Plan and manage the scope. Plan and manage the budget and resources. Plan, prepare, modify, and manage the project schedule based on the methodology that you've chosen. Plan and manage the quality of products and deliverables. Integrate project planning activities. Plan and manage procurement strategy. Establish the project governance structure. And this may be laid out in larger corporations, and you may not have that much control over it. And then plan and manage project or phase closure. What is your definition of done? That's one key thing that you really need to establish. How do you determine if something is done? And analogous to that definition of ready. Okay. And then some questions to reflect upon. Why do you think developing project and scope management plans is important? Why do you think it's important to collect requirements, find scope, and create a work breakdown structure? Just some things to think about. Okay. We've got some time for questions. Either Will's muting everybody when they come off mute, or we don't have any questions.
Yeah, I just solicited everyone in the chat room to see if there were any questions. I don't have anything yet. But
okay.
Of course, everyone can unmute themselves and ask.
Yep. If you don't have a question, please feel free to drop.
Harry, didn't the last session that we just completed, spring, wasn't there a special presentation or a special course on critical path? Do you remember?
In which one? Will?
the last group, the last class, the last group of sessions, I thought there was a special night that went over critical path. I don't remember though. It would have been recorded.
Yeah. I know we used to go over it very intensively in the old presentations. But,
Yeah.
I mean, that's a good topic to talk to your mentor about. Okay. Looks like people are voting with their feet. Have a good night. And
Thank you, Harry.
if you have any other questions, to come up later, you can always shoot me an email.
Thanks, Harry.
Okay.